Hello students, welcome back to the channel. Today we are going to learn one of the most important topic in numerical methods, numerical integration. We will learn three important rules. Many students get confused when to use trapezoidal rule, right? When to use Simpson's one-third rule, when to use Simpson's 3 by 8 rule. After watching this full video, you will understand why numerical integration is needed, all three rules in the easiest way, how to remember the formula, which rule to apply in examination, common mistakes students make, so watch till the end with full focus. Suppose we want to calculate area under the curve, right? Normally in calculus, we solve such examples by integration, right? Suppose we have an integration like this, integration from a to b, f of x into dx. It means that we are calculating the area, we are calculating the area, bounded by this curve. Suppose curve is like this, from x is equal to a, this is the starting point, right? And till this x is equal to b, this is the end point, or sometimes we may call it as x0 and xn, right? So same logic we are going to use it here, right? But why we have to go for a numerical integration? I will tell you the reason. Sometimes this function is difficult. The function which is going to come here, which is very difficult. Okay. Function cannot be integrated directly. This may be the reason. Only table values are given. No, they won't provide you, or there does not exist, right, a function. They will give you only table values, right? Calculation is too lengthy if we use analytical method, right? Then we have to use this numerical integration. I think now it is clear that why we have to study numerical integration, and it plays a very important role when there is irregular field, right? It means finding approximate value of area under the curve using these three formula. So first of all, we will set up, right? Basic setup for all three rules. That is, we divide interval, we divide interval from x0 to xn into equal parts. Remember, again, I'm going to take this as a simple curve, and I'm going to divide this interval. This is the starting point, which is x0, and this is the end point, this is xn, and I want this area under the curve. So I'm going to divide it into equal parts. Remember, equal parts. Okay, so if I draw it like this, it is divided into two parts. Again, if you take this n as 4, then it will be divided into 4 parts. So in this way I'm going to divide it into equal parts, and I'll try to take h very small, right? And what is the formula to calculate h? To calculate the formula, to calculate the value of h, formula is xn minus x0 divided by n. Xn is the last value of the interval, first value of the interval, and divided by n. We will get h, right? So after finding h, we have to find corresponding values of y also, right? So first value is x0, and the value, corresponding value is y0, x1, y1, x2, y2, and so on, in this way xn and yn. So let us study all three rules. First rule is trapezoidal rule, right? So what is the idea here? In trapezoidal rule, I'm going to consider trapeziums, right? You can see here, this is a trapezium, right? This is a trapezium. This is irregular field, right? we have to find area under this curve, right? Area under this curve, which is irregular. This is not a straight line or this is not a parabola. This is irregular field. So here trapeziums. In this method, I'm going to consider trapezium. This is a trapezium, right? So each strip becomes trapezium here. So what is the formula? Come to the point, for exam point of view. What is the formula? Here I'm going to restrict now the data, which is x0, x1, x2, x3, x4, x5 until x6. Then this will be corresponding y4, y5 and y6, right? So the first value y0 and the last value y6. So here capital X, which is sum of extreme values, which is y0 plus y6. Here also I have written y0 plus y6. I'm going to tell you the trick how to remember this formula. First value and the last value, y0 plus y6 plus remaining. What are the remaining ordinates here? y1, y2, y3, y4 and y5. Add all these ordinates, right? And remaining ordinates, and you multiply it by 2. So the formula is, in a shortcut way, we can say that integration, right? Integration from a to b f of x dx. And if you want to remember this formula, it's very simple. H by 2 for trapezoidal rule, x plus 2 times r. X represent first value and last value. Here y0 and y6, and r is the remaining ordinates 1, 2, 3, 4 and 5, right? Don't count y6 here because already y6 is taken as a part of x. So this is x plus 2r. This is the simplest formula. So what are the steps to solve such an example? We need to find h, find all, right, y values. Here these are the y values. Then find, right, find the value of capital X. What is capital X here? First and the last. Addition of first and the last. Always sum, right? Then the middle, all values we have to add. We are going to denote it by R and apply the simple formula. You will get answer by using trapezoidal rule. Clear? Now we will move to the next rule. Next is Simpson's one-third rule. What is the idea here? Instead of straight lines, I'm going to use parabola. Instead of straight lines, let us use the parabola here, right? Parabolic structure. Let us use like a parabolic structure here. So using parabola, instead of lines, I'm going to consider parabola. This is the idea. So more accurate than the trapezoidal rule. This gives you more accurate than the trapezoidal rule. So important condition. What is the condition? When to apply Simpson's one-third rule, right? To apply Simpson's one-third rule, number of intervals must be even. Number of intervals must be even. That will be 2, 4, 6, 8 and so on. But they must be in even in number. For example, suppose y x0, yz, x1, x2, we can use here Simpsons. Or if you consider till x4 also, we can use Simpson. X5, x6, here also we can use Simpson. It means that the number of intervals must be even, or you can remember like this value must be even, y2, y4, right, and y6. So this is the trick that you have to remember. What is the formula? Simpson's one-third rule. Here it is h by 3. Compared with the trapezoidal, there it was h by 2. Now in Simpson's one-third rule, it is h by 3. Again, this is first value and the last value. We are going to call it as x, capital X, capital X, plus 4 times you need to connect odd number row, right? This is 1, then 3, then 5, and so on. So 4 times sum of odd numbers plus 2 times even numbers y2 and y4, right? So this is a formula h by 3x plus 4o plus 2e, right? 4o plus 2e. Here I am going to take only odd numbers, remember, and e means sum of extreme ordinates. Ordinates means the values of y I'm going to consider. That's the reason I'm going to call it as ordinate, right? Okay. I hope this rule is clear, known as Simpson's one-third rule. Right. Now we will move to the next rule, known as Simpson's 3 by 8 rule. So in Simpson's 3 by 8 rule, here the idea is right? Uses cubic curves. He is going to use cubic curve. Important condition. Number of intervals must be multiple of 3 now. That is 3, 6, 9, and so on. What is the formula of Simpson's 3 by 8 rule? This is 3h upon 8, right? 3h upon 8. Again capital X, which is y0 plus y6. If I have restricted this set like this, x4, x5, and x6 corresponding y4, y5, and y6 here, and three times remaining, right? Three times remaining plus two times multiple of 3. So you can write like this: 3 times remaining plus 2 times multiple of 3. This t represent multiple of 3, right? This is maybe y3. y6 won't come here because y6 is already considered if n as 6, right? So in this way we have to take, sorry, 2 times, yeah, multiple of 3, multiple of 3. Here it is 2 times, here it is 2 times, 2 times multiple of 3. Clear? I think the formula is clear. Now we will move to the example. Okay, let me solve you one example using all 3 rules, right? This is the example which we are going to solve it. That is, we have to integrate this function, right? Integrate this function using trapezoidal rule, Simpson's one-third rule, and Simpson's 3 by 8 rule. These are the 3 rules we have uh, written over here. This first is always capital X, right? Yes, in all 3 rules this part is common, and we know that if I take n is equal to 6 to calculate the value of h, what will happen? We can use first rule because there is no restriction on n to use trapezoidal rule, right? Remember. For Simpson's one-third rule, this must be even. So I'm going to take n as 6. So it fulfills the condition of Simpson's one-third rule. And if I keep n as 6, it will also fulfill the condition of 3 by 8 rule as well. Right here, x stands for sum of extreme values and r is denoted by remaining. Okay. So let us start trapezoidal rule, right? So in step number 1 we will compare the given question or the given integral I is equal to from a to b f of x into dx. Now you can see the value of a and b, right? So here from point 2 is a, 1.4 is b here, and your f of x is this question, right? This part is there here, f of x, which is sin x minus log x to the base e, means in the calc we have to use ln. All of you remember, when there is a base is e in calculator, we have to use ln, not log. Don't use it here. It is base is 10, right? Here it is clearly mentioned that the base is E, so we have to use ln. Keep your calci in radian mode first of all, because there is a trigonometric function, right? We need to keep your calci in radian mode. So this is your f of x. F of x is sin x minus log x plus e raised to x. A0 is 0.2, b, sorry, a is 0.0, 0.2, b is 1.4. A0 means the starting value, x0, right? And this b means xn, right? B means xn, last value. So I'm going to take here n at 6, which is even, and also multiple of 3 means we can use Simpson's 1/3 rule as well as 3/8. So step size h is equal to b minus a upon n, which is 0.2. This is the formula for trapezoidal rule. Before that, we need to calculate all the values of y, right? So this is the table. Use calci. There is an option in the calci. The table option is there. There you need to enter the full equation f of x, and you can start with 0, right? You can start with sorry, 0.2. You can start with 0.2, and you can end with 1.4, and if you enter step size as 0.2, you will get all these values, right? You will get all these values. In the calci, you have to use table mode of the calci. Okay, now these are the values rounded up to 4 decimal places, right? So here this is your y0, this is y1, y2, y3, y4, y5, and y6. This is the y6 and this is your y0. If you add these two numbers, you will get x, right? So here addition of these two is your x. H is 0.2 divided by 2. This is x plus 2 times r. R means remaining. All values you need to add from y1 to y5. So finally, if you enter in the calci, your answer is 2.8724 by using trapezoidal. This formula is very simple. Just you need to enter the correct values. All of you remember, right? Now we will move to the Simpson's 1/3 rule. Clear. Formula is very, very clear. Simpson's 1/3 rule here, h by 3. Then this is the x, which is first time last, and 4 times odd values, and 2 times even ordinate, right? Odd ordinate, even ordinate. So here this is your first and last, which is a part of capital X. Then if you take next is this is first and last, right? And the next is odd ordinates. Odd ordinates means here this will be y1, this will be y3, and this will be y5. So 4 times y1, y3, and y5 plus 2 times even, this will be y2 and y4. So 2 times 2 values are considered. Just add, enter the correct values and use the formula, and answer is 2.8548 by using Simpson's 1/3 rule. Right? Now we will move to the next rule, which is Simpson's 3/8 rule. In Simpson's 3/8 rule, we know the formula 3h upon 8, right? Starting 3h upon 8. This is capital X, first and last, y0 plus y6, plus uh, 3 times remaining plus 2 times only multiples of 3, right? Only multiple of 3 means here y0, y1, y2, y3. This is only multiple of 3. So 2 times only one value, 2.1761, which is y3. And all remaining then y4, y5, and y6. So here 1, 2, 4, 5. 1, 2, 4, 5. These are a part of remaining r, 3r plus 2 times only multiple of 3. So in this way, we can calculate the value of this I using Simpson's 3 by 8. Now, I'm going to tell you very interesting result. Very interesting result. Right? I'm going to solve this equation by analytical method. Right? I will solve it exactly. We will try to find the exact solution, and then we will compare, right? Which method is better, which method gives you better answer, right? So this is the exact value of the integral. Okay, exact value of the integral. Let us solve it. Okay, let us solve it. Suppose we want to solve this integral. Suppose we want to solve this integral. This is a definite integral. So first of all, let me. I know the integration of directly sin x, but some steps are required to find the integration of log x. Okay, I'll solve integration of log x separately here. Integration of log x into dx. Uh, to solve this integral, we have to use UV rule. UV rule. Log x into 1 into dx. So what is u here? U is log x and v is 1. If I use integration by part, log x as it is, then integration of 1 into dx minus derivative of log x, which is 1 by x, into integration of 1, which is x into dx. Right? I hope the formula you know the formula here. Formula is integration of u into v into dx is equal to u as it is, integration of v dx minus derivative of u, right, and integration of v dx into dx. This is the formula, all of you remember, right? Then log x, this is the first term, integration of 1, right, integration of 1 is x minus, here x and x is cancelled, so integration of dx means integration of 1, which is x only. So this will be the integration of log x, right? We know the integration of sin x, which is minus cos x, minus integration of log x is log x into x minus x, plus integration of e raised to x is e raised to x, and I'm going to integrate this from 0.2 to 1.4. So finally it will be minus log x. I'm going to multiply with minus sign. So here it will be plus x and minus x into log x plus e raised to x from 0.2 to 1.4. Now you can put the upper limit and lower limit using the calc. Here in place of x you can put the upper limit, which is 1.4, minus you can put the lower limit, which is 0.2, and you can calculate the answer using the calc. Keep your calc in again radian mode. So what will be the answer? If you do all these calculations using calc, your answer is approximately 2.8550, right? This is the exact answer. This is not going to change, right? This is not going to change. Now let me compare with the values we have obtained from all three rules, right? So in trapezoidal rule, you can see here, in trapezoidal rule, uh, answer is 2.8724 and exact value is 2.8550, approximately up to 4 decimal places. So definitely there will be error, right? Now you can compare with the answer of Simpson's one-third rule, which is 2.8548, 2.8548, right? And this answer is comparatively more accurate, right? more accurate if you compare with the exact value of the integral, right? And this 3 by 8 rule is 2.855, right? 8555. So it means that Simpson's one-third rule is most accurate for this example, remember, for this example, right? Now, take the screenshot of this, everyone. This is very, very, important for you. Here, all the steps are mentioned. First of all, you need to find the value of a, b, and you have to identify for x. Take n at 6 here. Then the step size is b minus a upon n. Then compute the values of y, right? Yeah, and here a round, okay, a rounded of to 4 decimal places. Then use trapezoidal rule, which is h by 2x plus 2r. Simpson's one-third rule, h by 3x plus 4o means odd plus 2 times even, right? Ordinates. And Simpson's 3 by 8, which is 3h upon 8, again x plus 3 times remaining plus 2 times only multiple of 3. So in this way, if you calculate, so for this example, it is very clear that Simpson's one-third rule is most accurate, right? If you compare when to use, when to use Simpson's, when to use trapezoidal, so comparison table is here. Condition. What is the condition here? If there is a condition on n, suppose n is an even number, we have to use Simpson's one-third rule, right? And suppose along with this n is even as well as multiple of 3, because 6 is a multiple of 3. It implies that we can use both the rules, right? We can use both the rules. And if there is no restriction on n, and if it is mentioned trapezoidal rule, you can use it. Then accuracy, this using trapezoidal rule, because trapeziums are going to consider, right? The idea is going to consider trapezium, you will get moderate answer. And accuracy is high in case of Simpson's one-third rule and 3 by 8 rule. And if you see easiness, trapezoidal rule is very easy. Simpson's one-third rule is easy, and this is moderate to use. I hope all three rules are clear. All of you revise, listen this video again and again, right? And be calm, patient. Definitely you will get full marks in upcoming examination. Thank you.